In this lecture, we're going to begin hypothesis testing. Now, I bundled chapters 10 and 11 together, and I just called it hypothesis testing. So as we go throughout this handout, it's going to be both chapters. So I don't necessarily look at them separately. So when I assign assignments also, it's just going to be under, the umbrella of hypothesis testing. So in this lecture, we're going to do an introduction. So when you hypothesize about something, you guys have probably heard the word hypothesis before when you hypothesize. It's like you believe something to be true, right? But you don't know for sure if you're 100% correct. But you have this suspicion, right? So that's really what we're going to be doing in this chapter. We're going to be having a suspicion about some parameter from the population, and we're going to try to gather enough evidence to support our suspicion. So, hypothesis testing is an example of inferential statistics. So, remember, inferential statistics is when we use sample information to draw conclusions about the population from which we sampled. But at the same time, we can never be 100% certain about the conclusions that we draw about a population based upon one sample, since a different sample selected from the same population could possibly lead one to draw a different conclusion about the same population. So it's going to be necessary to use probability to help explain how reliable our conclusions are. And we're always going to assume that sample data was selected randomly from the population. So, in order to conduct a test, you have to have two hypotheses. And we always begin a hypothesis test by stating the claims of the statistical test. And these are the two hypotheses that we're going to formulate. The first one is called the null hypothesis. And we denote the null hypothesis by the symbol H sub 0. This is the statement being tested, which states a value for a population parameter, and we're initially assuming it to be true. And it's formulated for the sole purpose of trying to reject it by seeking evidence against it. Then we have this other hypothesis called the alternative hypothesis, and we denote that by H with a little sub A. That A stands for alternative. This is the statement about the value of a population parameter, which is different from the value that's stated in the null hypothesis. This is the hypothesis that's suspected to be true, and it's only going to be supported by rejection of the null hypothesis. And we have to get enough evidence to be able to reject the null hypothesis. So before we get into any examples, I like to parallel a statistical hypothesis test to a trial in the court of law because I think it's easy to understand that way. So let's say we have a trial in the court of law, in court, right? So imagine the TV shows you've seen, Law and Order, any movies, Dateline 2020, right? So all these different shows where, they show a trial and somebody's on standing trial for committing a particular crime, and then you have the jury. So I don't expect you to know, all the specifics of a trial in court, but let's just look at the overall picture. This is what I want you to understand, because then I think it's going to be really easy to relate this to a statistical hypothesis test. When a person is on trial for doing something, whether it's robbery or murder, let's just go big or go home. Let's say murder. So somebody is on trial for murder. What do we have to assume about that person? So, if you're familiar with how a trial works, maybe you've taken a law class before, criminal justice, or even watching movies, right? What do we always have to assume about a person that's on trial for anything really, but let's just say murder? We always have to assume that the person is innocent. It doesn't matter if you think they're guilty. We have to assume that every person that's on trial for a particular crime is innocent. So you could think of that as the null hypothesis. So think of the null hypothesis as what is assumed to be true. So in court, the null hypothesis, which going forward, we're just going to use the symbol H sub 0. That's how we're going to write the null hypothesis, is that the person is innocent. We have to assume the person is innocent, whether you think they did it or not. And then the alternative, think about it this way. So H sub A is the alternative hypothesis. What is the purpose of a trial? Both sides, right? They both speak, they give their, evidence and reasoning. And at the very end of the trial, whether it's days, weeks, months, the jury, right? So those 12 people that are sitting there listening, watching, they're absorbing every little statement, every piece of evidence. They have to make a decision whether to still say, you know what, the person is innocent, or you know what, there is enough evidence. I feel like the person's guilty, and goes with the alternative. So that's the purpose of having a trial. It's not to find the person innocent, because we're already assuming the person's innocent. It's to gather enough evidence to find the person guilty. So the alternative, or the suspicion, what we're trying to prove is that the person is guilty. And what happens if there's not enough evidence? Well, then we can't find the person guilty. We have to still assume that they're innocent. So think of the null hypothesis as the statement that's believed to be true. And in statistics, we're testing a parameter. So it's the statement about the parameter that is assumed. We'll use the word assumed to be true. And then the alternative is the statement about the parameter that is suspected to be true. So the whole point of a trial is to gather enough evidence to go against the null that the person is innocent, and to find the person guilty. So it's going to be the same in a statistical test. Think of it this way. The point of formulating the null hypothesis is to try and reject it by seeking evidence against it. If you don't find evidence against it, or enough evidence, strong enough evidence, then you can't go against the null, and we have to keep assuming it's true. So let's just practice. And I'm going to keep going back to this example about a court trial, because I think it's easy to relate to, because a lot of us have seen movies, taken classes, watched TV shows, so we're kind of familiar. So let's just practice formulating the null and the alternative hypotheses in 4 different situations. So let's look at example 1. So we want to state the null and alternative hypotheses for the following research. A college newspaper claims that full-time college students work an average of 20 hours a week. A marketing professor who believes this claim is too high decides to conduct a study to test the newspaper's claim. So we have 2 different statements here. Now, we're always going to call the null H sub 0, and the alternative is going to be H sub A. Remember, the alternative is the statement about the parameter that we're assuming is true, or that we believe to be true, and then the alternative is what we're suspecting. But in a statistical test, you have to identify your parameter. So in other words, from the population, in this case of full-time college students, what is the parameter of interest? What are we studying about them? It's the average amount of hours that they work per week. And that average, since we're talking about all full-time college students, is mu. So you have to identify the population parameter of interest. It's the average or the mean or mu in this case. And what are we assuming about the average number of hours that a full-time college student works? What is this first sentence saying? It's saying that it's equal to 20 hours a week. So let's write that down. And we're going to use symbols. We could write it out in words in a sentence, but statistically, it's easier just to write it using the appropriate symbols. So the null is that mu, the mean number of hours that a college student works per week, is 20 hours. That's what we're assuming to be true. But then this marketing professor comes along and says that this claim is too high and decides to conduct a study to test the newspaper's claim. So that's a suspicion, right? The marketing professor has a suspicion that that claim is too high. So that's going to be the alternative. So the marketing professor believes that the average number of hours is really less than 20 hours, right? Because if you think that's too high, you think it's really lower than that, right? Or less than. So that's how we state a null and an alternative hypotheses. You have to use the appropriate symbol for your parameter, and then the null is always going to be equal. It's going to be that the parameter is equal to some value. And then the alternative is just going to be something different than an equal sign, either less than, greater than, or not equal to. And we're going to test both the mean and the proportion once we get into hypothesis tests, the actual tests. So example 2 says the recommended dietary allowance, or RDA, of vitamin C for women is 75 milligrams per day. A hypothesis test is to be performed to decide whether adult women are on average getting less than the RDA of 75 milligrams per day. So we're looking at adult women, that's the population. And the parameter of interest is the average amount of vitamin C that they're getting. So on average, what's the amount of RDA, the recommended daily allowance for vitamin C? Well, it's assumed to be, so the average or the mean, we're assuming it's 75 milligrams per day. But a hypothesis test is to be performed to decide whether adult women are on average getting, here's your key word, less than the recommended amount of 75 milligrams per day. So the alternative statement or the suspicion about the average amount of vitamin C is that they're really getting less than 75 milligrams per day. So the alternative would be that mu is less than 75 milligrams. So all we're doing is practicing stating the null and the alternative hypotheses. We're not actually conducting a test. This is only the first step of a test. But we can't conduct a test unless we're comfortable doing this. So I want to do a couple of practice questions. So number 3 says a health insurer has determined that the reasonable and customary fee for a certain medical procedure is $1,200. They suspect that the average fee charged by one particular clinic for this procedure is higher than $1,200. The insurer wants to perform a hypothesis test to determine whether their suspicion is correct. So let's state the null and the alternative hypothesis. So the null is what we're assuming to be true about the parameter. And my parameter in this case is the average fee that's being charged for a particular procedure. Now, it's believed that the reasonable and customary fee is $1,200. That's what it's assumed to be. So mu is assumed to be equal or believed to be equal to 1,200. But now there's a suspicion that the average fee charged by one particular clinic for the same procedure is higher than 1,200. So the alternative would be that the mean price of this procedure is higher than or greater than $1,200. And that would be my null and my alternative hypotheses. Let's do one more just to make sure we're really comfortable. And we're going to do this, for every single test that we perform. In the past, the mean running time for a certain type of flashlight battery has been 8.1 hours. The manufacturer has introduced a change in the production method and wants to perform a hypothesis test to determine whether the mean running time has changed as a result. So, null and alternative hypotheses. That's what we want to write down right now. My parameter of interest about these certain type of flashlight batteries is the mean running time, right? On average, how long does it live for, the battery? Well, the assumption is that the mean running time is equal to 8.1 hours. That's what it's been in the past for this certain type of flashlight battery. But the manufacturer introduced a change in the production method and wants to perform a hypothesis test to determine whether the mean running time has changed as a result of this new process. So there is a suspicion that the mean running time has changed from 8.1 hours. Now, changed doesn't necessarily mean higher or lower. It just means that it's not the same as, right? 8.1. So changed means not the same as 8.1. So a way to write that in symbols is not equal to. So the alternative would be that the mean running time is not the same as 8.1 hours. It's changed, in other words. So I'm going to wrap up this lecture here. In the next lecture, I'm going to give you some key words to look for in order to determine what inequality you should be using for the alternative hypothesis. And then I'm going to go over types of tests.